In previous video, I defined electric field and electrical intensity. You know, by definition, the concept of electric field is the force acting by unit positive charge. Means electric field is measured in terms of force acting by unit positive charge. For example, you define speed. You have not seen what is speed, but speed is defined as distance traveled per unit time. That is distance only, which has been traveled in time. Similarly, electric field at any point is the force acted by unit positive charge. Now here, we will try to find out how a strong field will be there due to a point charge to at such distance r. So let a point charge be placed at point O, and there is point P where we want to find electric field. It is a distance r from it. Now, to find the electric field at P, we consider test charge Q0. You can write all these things. So to find electric the trouble of hawkers is very great. They keep on crying again and again. So we want to find electrical intensity at P due to charge Q placed at point O. O meant here like origin. So from Coulomb's law, force acting on test charge Q0, if this is placed in vacuum, is Q0 upon R square, and R cap is unit vector, where R cap is unit vector, whose direction is along OP vector, O to P. P may be here, so OP this way. We have taken just on the right hand side of Q. You can take here, so OP this way. This is the force, or F upon Q0 is equal to 1 upon 4 pi epsilon 0 Q upon R square R cap. F upon Q0 is defined as electric field E. So E is equal to 1 upon 4 pi epsilon 0 Q upon R square R cap. This is the electric field due to point charge by distance R. Magnitude of this E is equal to 1 upon 4 pi epsilon 0 Q upon R square, only magnitude. If the charge Q is placed in dielectric medium, if charge Q is placed, charge Q is placed in dielectric medium, then magnitude of electric field our NCERT book write only electric field, they never talk about electric field intensity. It is given by E equal to 1 upon 4 pi epsilon 0 K Q upon R square. For vacuum, you can write directly magnitude of electric field at distance r from point charge is 9 into 10 to the power 9 q upon r square. Here you know what is this K. I told you K while defining Coulomb's law in the definition, in the statement of Coulomb's law. I told you K is dielectric constant. Its value varies from 1 to infinity. So electric field inversely going square of distance. So it will be decreasing from distance from point charge increasing. So if we plot a graph between E and R this side and E this side. How many? 9 kilo electric field. E is the already without arrow. So it means I am writing magnitude of electric field. So it will be infinite at Q0, so it will decrease like this. Inversely proportional to square of distance will become 0 at infinite distance. I have not joined this R axis. ये x axis y axis मान लीजिए हमने तो we never allow the curve to touch x axis because it means field is 0 while field will be 0 at infinite distance. So this is the electric due to a point charge. Now I come here to another point, another topic, which is called the point is there, electric field lines. Electric field lines. Dear student, try to understand what is electric field. Electric field is the force itself, and every force has its line of action. For example, I am putting here this positive charge Q. If I place here trace charge Q0 which is positive here, so the line joining them, the force will act this direction. तो force on trace charge point this direction. अगर मैं इसको यूज लूँगा, if I take Q0 as 1 coulomb charge, so direction, this is the called line of action of force, and hence it may also be called as electric field line. In some books, this heading is not written like electric field lines. It is written like this: electric lines of force. Electric field lines of force. Electric lines of force लिखते हैं हम. It is ridiculous here because electric field itself is force. Means field line का the line along which force action by positive charge is there. That is called electric field lines. So electric field lines are by definition ये याद करनी होगी. You have to learn this thing only. I am writing here electric field lines. Field lines are continuous straight lines or smooth curves which are drawn in such a way that tangent drawn at any point any point of these curves gives the direction of electric field. Gives the direction of electric field. Tangent drawn at any point of this curve gives the direction of electric field. So these imaginary straight line, continuous straight line or smooth curves which are drawn in such a manner that tangent at any point gives the direction of electric field. I mean, electric lines are continuous straight line or smooth curves which are drawn in such a way that tangent drawn at any point of this curve gives the direction of electric field, and direction of electric field is the direction of force on positive charge. This has to be remembered. I mean, by here find positive charge. So you want here field. So you place +1 coulomb charge divided and force this way. So this is a line of field here. अगर मैं यहाँ आता हूँ तो ये ऐसे, तो force acts along this line. The line of action of force acting by charge at any place gives the electric field lines like that. Now we will draw the pattern later. So let me draw the pattern of electric lines. These are given in different books. Pattern of field lines. Patterns of field lines. I will take properties of field lines in next video. Suppose here it is point positive charge. So field lines will be originating from it, will be going towards infinity, and you know from formula magnitude of electric field due to charge Q is 1 upon 4 pi Q upon R square. So when R is infinite, field will be 0. So this is the pattern of field lines due to a point positive charge. Point positive charge. Now if we have negative charge, negative point charge, minus charge is there. So field lines like this. Only. This is the pattern of field line due to. In our books, lot of things, 2 or 3 pages are filled in NCERT on field lines. So these are important because we represent electric field lines to represent electric field at any point. If we have two equal and like charges, two suppose equal means plus Q charge, plus dono. Then pattern of field, it will be like this, here it will be like this, like this, this one, and this one. But here, the pattern will go like this. Because here field will be 0. Field will be 0. Pattern of field lines like this. So these are electric field pattern due to two equal and like. If both are negative, only direction of arrow will change. I mean, you can draw the pattern from different book. Actually here diagram has gone wrong. Some slippery point is there. So I am unable to draw this diagram. Please draw the diagrams in exam. The diagram are asked. If it is electric dipole. Electric dipole, I told you in last video, system of two equal and unlike charges. Equal and unlike. Minus q plus q. So pattern of field like this. Dear student, be very careful. Pattern of field line like this. Okay. Don't think that field is only along the field here also. We can't draw, no? You see, everywhere line. No. So we draw like this. Pattern of field line due to dipole. And then it is like this. But arrow, to put arrow you must here. I mean, these are pattern of field line due to dipole. Pattern of field line due to dipole. They start from positive charge, terminate negative. Now see here. Actually you have learned field due to point charge q at distance r and magnitude is given by 9 into 10 to the power 9 q upon r square. If this dipole has minus q charge and plus q charge, so generally you are asked what is the, and the length of dipole is taking 2a. So you are asked what is the electric at midpoint. So here what you do, E बराबर 9 10 minus q upon r square करते हैं इसका, plus q square can be added, field is 0. But field here is never 0, because field is the force on unit position charge. This position charge external repulsion, this negative attraction, the same way. So field will be twice of the field of single charge, never 0. But once there was question. In one exam, I gave, in 1 year, I gave this question in first test, half yearly and pre-board. The student who wrote it 0 kept on writing 0. He did not realize why this question is there continuously. He did not notice his error. So, and this also asked, give the direction and magnitude of electric field to dipole at midpoint. So, direction from positive to negative और opposite dipole. Direction dipole कहते हैं negative to positive. Dipole. I had done this way. So this is very important point here. Now, electric field due to a point charge near a metallic plate. Here is positive charge near metal plate, which is placed on earth. Earth is comes the earth surface has the plate, metal plate. Okay. It is in touch with earth. Because metals have free electron, due to induction they will have a negative charge here. Positive charge will go to earth. So pattern of field line like this. In one exam, it was there, board exam. Draw the pattern of field line. Because NCERT has no such diagram. So some questions are asked, you can go this way also. I mean, these are the pattern of electric field lines due to different configuration. We will be learning further about electric field line, and in next video I will tell you properties of field lines.